In this video, we'll recreate this fantastic burn reveal. We'll set up an xpExplosiaFX simulation to sort out the smoke and fire, and then we will set up an advected cloth sim to make it look like the plastic is burning and melting away. So, let's jump into Cinema 4D and get started with this one. So we're starting our 5:4 burn scene by opening our 5 shrink scene, which is our basic shrink wrap, which shrinks the bag around our number 5 and our number 4, because we need to borrow some elements from this one to do our 5 burning and tearing scene. So what do we need from this? Well, we are going to need our subdivision surface with our plastic bag. We're going to need, obviously, the cache object that pertains to this plastic bag. We're going to need our number 4 as well. So we'll just take all of these through, and let's just go to our cache tag and just make sure we've got copy tag data ticked. Good. So then we can just select all of those, hit Control C to copy, and let's go into a new file and we'll paste those in. Very nice. So it's all come through. Excellent. And there's our really nice shrink. So what do we need? Well, what we're going to do is, once this is shrunk down into this state, we then need to simulate it burning and the plastic looking like it's kind of melting away, even though obviously that's not what's happening under the hood. So what we need is, we want to kind of create a new polygon object which is in this pre-shrunk stage. So how are we going to do that? Well, there's a couple of considerations here. What we're going to do, let's just hit ND to see the lines. We are going to create a new cloth simulation from this object. But if we make a cloth simulation using our subdivision surface amount of polys, there are going to be a huge amount of cloth particles in this, which means that we're going to get slower simulation times. So instead of making this editable with our subdivision surface, creating 2 subdivisions, what I'm going to do is just put that down to 1. So we've got fewer. Now, what we could do is just deactivate the subdivision surface and just make our original plastic bag editable and use this for our new cloth sim. But my feeling is, because we're going to start using tearing, which looks better with more polygon detail, this isn't going to be high enough resolution mesh for us. So this is what we'll do. We will reduce our subdivision surface down to 1 subdivision. So it's still subdivided and smoothed, but it's not the dense 2 subdivisions that we've had for the render. And we'll return it to that state a little bit later. So what do we want to do? Well, look, we want to get to the point where it stopped animating. And then I'm just going to, look, let's just delete the cache tag and the cloth tag. We can then delete the cache object. Let's go to our subdivision surface, right click, and let's just put current state to object. Click on that, bring this down. Now I'm going to delete my subdivision surface and plastic bag. And now we have a polygon object, which obviously doesn't animate. This is just it in its static state. Great. So let's just rename that whilst we're here. Let's just call that subdivision ×1 cloth. And that just tells me that it's my original cloth object, but it has been baked down with 1 extra subdivision. So I know what I need to add on top of that once we've sorted out the animation. Great. We don't need our number 5 number either, so let's delete that. So all we are left with now in our scene is our bag and our number 4. Our number 4 already has a collider tag on, set to outside, which is what we want. Perfect. So now we're ready to start. Now, this burning transition, we want this bag to set on fire from this bottom corner and then spread up, burn away, and look like it's burning and melting the plastic away as it rises up, revealing what is underneath it. And we know that this needs to be approximately a 3-second animation. That's going to give us a really nice burn speed to then reveal the number 4. So what I'm going to do, let's just keep, I've got my project settings set to 30 frames a second. So let's just keep this on 90 frames, which means that this is our animation time. We want the burning to happen, spread across, and by the time we've got to the end of our timeline here, we want everything to have really disappeared out of the frame, like floated up with the fire, revealing the number 4 beneath. Excellent. So now we've got all that set up, let's do the same old thing and get organized here so we can save this file as it is. Let's go to File, Save As, and let's go to our MoGraph countdown. And what do we need to do? Well, we need to make a new folder first, don't we? So new folder, and this is going to be XP Countdown, and this one we'll call it 5 burn. Actually, we don't need a capital B. Burn, right? And before we hit enter, let's just copy that name, and we'll put that. Let's go into that folder. Before we do the file name, let's make a new folder and call this cache. Okay, and then the file name. Let's paste that folder name in, and let's put our version suffix. Excellent. Hit save. Right, so now we're organized and we're ready to go, and you can incrementally save as we go here to make sure we don't lose any information. Okay, so let's get going with this. What we need to do is create our new cloth simulation. So let's go and select our subdivision cloth, and we'll go to xParticles, dynamic objects, cloth, and let's create cloth, which brings in all our cloth objects. We don't need gravity, we can delete that. And I'm just going to deactivate those constraints for now as well. And once we've kind of got an animation going, we can play it and see what it looks like with the constraints. This, of course, remember, is the cloth particle-to-particle collisions to stop the cloth intersecting. We'll play it with and without to see whether it's necessary. There's a chance we might not need it, because remember, this cloth is going to be hidden behind fire. And if we don't need the constraints, that's an advantage because it'll simulate more quickly. But we'll look at that a bit later. Fantastic. So let's go to our emitter and let's just change the display mode from dots to circles so we can see what those cloth particles look like. So there we've got all our nice cloth particles. Fantastic. And let's just set, before we move on, let's go to our cloth tag, which is on the object, and let's just adjust those iteration settings and strength settings, similar to the settings that we had in our original cloth simulation. So iterations down to 4. This will make the simulation less stiff. It'll make the cloth look more kind of more able to kind of stretch and bend, which is obviously what plastic would be like. And we'll take away the shear and the bend constraints, so there's much less strength in those in overall constraints, which means it's going to be really pliable and able to kind of crease up, which is what we're going to want. And we'll just leave that as that for the time being. So if we hit play, we're not getting any animation, of course, because we have no forces in the scene moving these cloth particles around, so everything's just remaining in a static state. So before we start looking at that, let's get a bit organized now. So now we've got all of our elements in the scene. Let's get organized by going to xParticles, and we will bring in a XP system sort. Let's click on that, and then it organizes everything neatly within our xParticles system. Let's just do a couple of things. We can go to the system and deactivate the icon and viewport, and we could put these, just for now, organize our bits of geometry into the other objects. Very nice. Okay, so what we want to do is we want our fire to gradually spread across this cloth. How are we going to do that? Well, before we do that, let's just set up the basics for the smoke and fire sim, and then we can explain and go through the techniques we're going to use to get this fire to spread nice and organically. So what we need to do is let's set that fire up. We'll go to the Dynamics tab, and we need to bring in an xpExplosiaFX domain. And this brings in this domain, and it is within this cube that we're able to simulate smoke and fire. So let's just adjust the bounds. You're always better off adjusting the bounds so your domain is as small as you can get away with. So remember, we haven't got our fixed camera position yet, but we know that the number itself is going to fill up, or the plastic bag is going to fill up the majority of the frame before it is in its shrunk state. So we're looking at a camera position about like this. So we need this explosion to be able to obviously be visible within our fixed camera frame, but then we also need it to be able to float upwards and kind of go out of shot. So we need this bit of extra height. Excellent. So that looks good. And you can see this grid on the back of our xpClothFX, and this is a two-dimensional representation of how this grid is divided up into three-dimensional voxels, which are cubes. So the cubes are this big. And the more you use xpClothFX, the more that you will visually be able to look at this grid, and it'll tell you whether or not you have enough voxel resolution to have the detailed fire and smoke that you require for your scene. Basically the rules are, this is adjusted by the voxel size parameter in the solver here. So if I increase the voxel size, you can see that the squares are much bigger. So this will simulate far, far more quickly, but the results won't be very detailed. If you try to render fire with a voxel size that looks this size compared to your camera position, it's not going to look detailed. It's going to look pretty awful. However, if your camera position was all the way back here, then actually a voxel size of 10 centimeters is going to look absolutely fine. That detail in the fire will look fine from this distance. So the voxel size is a very relative parameter. It's relative on scene scale, camera position. So for us, just so we start getting relatively fast simulation speeds while we're setting things up, let's just put the voxel size to, say, 5 centimeters. Okay, so what we could do, we could set our geometry on fire. And to do that, you just go to Tags, xParticles Tags, xpClothFX Source. And now if we hit play, you can see that our bag is set on fire. Let's just deactivate the cloth modifier, and we can deactivate our emitters as well. So now it's just going to solve for the fire. So now look, our whole bag is set on fire. Let's go to the xpClothFX mode. I prefer to put, by default, the display mode is on slices. I like to use grid and then increase the level of detail of that grid. There we go. So now we can see we've set our bag on fire. But that's not what we want. We want our fire to spread across the bag. So how might we do that? Well, instead of setting the bag on fire, let's just delete that tag. We are going to use the emitter, the cloth modifier is birthing particles with to set on fire. So let's just go forward a frame. So what we're able to do is we're able to use these particles as an emitter source. So how do we do it? Well, it's a two-step process. First of all, we need to go to the emitter. We need to go to the Extended Data tab, and we need to go to this Physical tab here, Physical Data. And look, we can give the particles a fuel value. So let's give them a fuel value of 2. Let's make the particles invisible, and then hit play, and we're getting no fire. Why not? Well, that is because we need to give it a tag. So let's go to xParticles Tags. Let's go to xpClothFX Source. And now it's able to read that fuel value. And look, now the particles are setting on fire and creating the sim. All right? So that's getting close to what we want. But obviously, everything is on fire. So how do we get this nice organic movement of fire across this surface? Well, this is the beauty of using particles as a source, because we can adjust these particles with all of the different physics solvers, all of the different modifiers and kind of questions and actions, everything within the xParticle system we can use to manipulate these particles, which will then become our smoke and fire sim. So it's an incredibly powerful way of creating explosions, because we've got the whole xParticles toolkit to control that emitter source. So what we're going to be doing, we're going to be using an infection to get to this nice organic spread. So how are we going to do that? Well, let's just deactivate our xPexplosiaFX for now whilst we set this up. So we're going to go to modifiers. Let's go to the control modifiers, and we have an xpInfectio modifier. So let's have a look at those settings. So what we have with Infectio is we have all of these settings, and we have the ability to create a seed object. So let's create a seed, and you can see in the, if I just drag this down, you can see now that there is a seed object as a child of the Infectio, and that seed object is this sphere. And all this says is, if a particle is within the volume of this seed object sphere, it will become infected. And then, depending upon the parameters that you set within the Infectio modifier, those infected particles will spread that infection to neighbouring particles. So let's just make our xpClothFX visible again, go forward a frame. So can you see that all of those cloth particles, the ones that are within our Infectio modifier, have become infected? And if I hit play, they're turning blue and then turning red. And what's happening is the blue ones are where the neighbouring particles are incubating that infection, and then gradually they will become infected over time, and then they will search out for more neighbouring particles to infect. They will incubate the infection and then become fully blown infected. And you get this really nice spread. So you can adjust these parameters with basically three settings. So the search radius is how far each particle is searching for neighbouring particles to infect. So if we put this search radius way up to say 20, you will see that there'll be far more blue particles, because it's been able to search for lots more within this 20 centimetre radius. So we've got much more incubating particles now. If we put this search radius up to, say, 60 centimetres, it's a massive search area. Let's have a look. So now it's searching this far, but can you see they haven't all turned blue? Why haven't they all turned blue? Well, it is because of this maximum infected number. What this is saying is each infected particle can only infect up to 3 other particles. And because it's searching in such a massive radius now, it doesn't have enough max infected to be able to infect every single particle. So if we turn this way up to say, I don't know, I'm guessing 10 might be enough. Now each red particle can infect up to 10 particles within this big search radius. So let's have a look. So we've managed to infect a lot, to infect and then incubate a lot more, but 10 isn't enough with a search radius this big. Let's put 30 particles and see if that's enough. Now we're getting close to infecting every single particle within this huge search radius. Okay? So these two kind of work in conjunction with us, depending on how many particles you have in your scene. It's all relative. Let's put this back down to default, and put this search radius back down to default. Because we actually want a relatively thin band of incubating particles. So what if we wanted them? It's a little bit steppy at the moment, isn't it? And it's moving across quite slowly. And we want this to spread across easily within our 90 frame scene time. So how can we do that? Well, we can speed up the incubating process, which means that they'll become infected more quickly, which means it'll then move along more quickly. And we can do that with the incubation multiplier. So let's just have a feel of what it's like on the default one. So there it is, pretty slow, and we're not getting full infection across our cloth. Even at the end of our scene time, no, look, we've still got uninfected particles. And what we want, we're going to get our fire to spread along with this blue border. So we need it to have completed. So let's put that incubation tab up to, say, 5. Let's have a look. Much quicker. Perfect. So let's see, are we going to get this to have completely spread by the end? Yeah. And then that's giving us time for the fire to kind of dissipate away. Really nice. So that's looking pretty good already. Now, the beauty with Infectio is, if I get my seed object, let's just hit Control and copy it. You can have as many as you want. So look, we can start with this one, and then if I move that on, infect these particles, then they spread. And let's maybe put it down here. Copy it again. Let's have a look. So you can get these really nice organic spreading. So now the fire could start on every corner and then meet in the middle. Let's just see if that one... So now the fire could go and melt from the inside and then meet in the middle for it to end. And so you've got a really nice bit of quite precise artistic control over what becomes a very organic movement. So this is priceless for this type of MoGraph animation where you want it to feel organic and natural, but you need that art directability. It's a fantastic, really easy to set up rig. So that is the basics of Infectio. Now we need to refine this rig slightly to get ultimate control so we can precisely place our xpExplosiaFX fire. So what we're going to do is go to our Infectio settings, and instead of using color mode fixed, so at the moment absolutely nothing is being created here by Infectio. All it's doing is changing the colour of our existing cloth particles in this organic way. That's all it's doing. There are no other clever things happening. It's just changing the colour. However, we want to have control. We want to kind of use this change of particle to drive where our fire is. And to do that, we need a bit more control. So instead of the color mode being set to fixed value, which is just this blue and red for incubated and infected, we want to put them into different particle groups. So to do that, let's change the color mode and let's put use groups. Now, if I hold Control down and click add group for an incubating group, and then I'll do the same, add group for an infected group. Now we get 2 new particle groups coming into our scene. Let's just put those into our hierarchy, and let's just rename them so we're organized. So we'll change this one from particle group. Let's just call this one group. Which one is this one? This is the infected. So infected. Oops, let's make it neat. Group infected, and our incubating one, we'll call it group incubate. All right, so if we hit play, this will look exactly the same, but there'll be one difference. Okay, the particles are looking different, aren't they? And that's because if we go to our group settings, you can see the editor display is set to squares. So let's just set that to circles. And now, there we go. We've got no difference and we're back to where we were. But now we've got it set to groups. This gives us really good levels of control. So if we reactivate xpExplosiaFX and hit play, every single particle is been given that fuel value and everything's burning as it was before, and this isn't what we want. We only want the blue and the red particles to be given a fuel value. We want them to be born with no fuel. So how are we going to do that? Well, let's go to the emitter, to the extended data tab, and let's remove this 2 fuel that we were giving that's been passed on to every single particle, whether it's in just the normal emitter, whether it's in infected or incubated. Every single particle has a value of 2, and that's not what we want. So let's put that back down to 0. So now no particles have fuel and we've got no fire. All right. So the way in which we're going to give only these grouped particles fuel is with a modifier. So let's go to modifiers. And just before we do, just have a look. In the physical data of the emitter, look at all of these different parameters. We've got friction, bounce, temperature, smoke, fuel, and fire, right? So let's go to a modifier. We're going to go to a control modifier, and we can control those physical attributes with this, the xpPhysical. Let's bring that in. And look, in the xpPhysical, we're able to control all of those physical settings that are in the emitter. Fantastic. So let's go to fuel, and we'll change fuel. We don't want to change it over time. We just want to set the value, and let's put 2. So now if we hit play, we've got exactly the same setup as when we set up this fuel value in the emitter. But because we've done it in the modifier, it means we can go to the Groups Affected tab of the modifier, drag in the infected, drag in the incubated, and now it's only giving that fuel value to those groups, and we're getting our fire spread. That's exactly what we want. The problem is that these just have a 2 fuel value forever, so they just keep burning and burning and burning and burning. We don't want that. We want them to be given a fuel value and just kind of it's spread and the fire kind of disappear from the corner as it moves. So the way we do that is we're going to map that fuel value. So let's go to the mapping tab of our physical modifier. We'll go add to add a map. And the parameter that we want to map is that fuel value. Let's click on that. And we don't want to map it to the particle age because all of the particles are born at the same time, so that wouldn't work. But what we want to do is map it to time in modifier. Let's click on that. So this does is, as soon as a particle is put into the incubating group, the timer is set. It's suddenly in this modifier. So this, if we just go forward a frame, have I made my particles invisible? Yes, I have. Okay, so let's go forward a frame. So this particle here is placed into the modifier on frame 2. This particle up here isn't placed into this modifier all the way until it goes blue, which is going to be nearer to frame, I don't know, 70. Let's have a look. This particle here goes into the modifier at that point, frame 56. All right. So let's change this down to 10 frames. And let's put this map like this. So what this is saying is, this y-axis here is the fuel value, which is 2. So if this dot is at the top, that means it has a fuel value of 2, the full amount. If it's at the bottom, it has a fuel value of, well, it's 0% of that, which is nothing. And the x-axis is this amount of frames, so 10 frames. So what this is saying is, as soon as a particle gets put into the modifier, it has a fuel value of 2, and then over 10 frames, that fuel value reduces right down to 0. And this is about, look, after 7 frames, it's put down to 0. So what this is saying is it should burn out. So let's just make those particles invisible. Let's have a look. We should have an initial burn, and then it should go out. Yeah, and look, it's going out, and it's spreading. Perfect. So that's what we want. Now we're kind of getting the look that we desire. Let's in the viewport, look, we've got a very smoky scene here. And in our render, we're going to be concentrating mostly on the fire. So in the xpExplosiaFX, let's go to the display tab. And in the display, let's change it from fuel and smoke to just fuel, which just gives us the fire. Okay. So now we've got our burn, 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 but then it burns out as it spreads across. Excellent. And what we can do is we can adjust how abruptly that burns out in our physical modifier. And look, we can kind of give it the fuel value. So it only has that fuel value for a much shorter time. And now it's kind of dissipating much more quickly. Okay, but I'm going to have mine. We want a good bit of fuel. There we go. Right. So that is kind of working at this point. I'm pretty happy with that. So what we could look at is increasing the... well, eventually we're going to increase the resolution of this simulation by decreasing this voxel size. But before we do that, let's move on to what we're going to do actually with our cloth. Because at the moment, we've got a really nice spread of fire, but the cloth is just completely static. And that isn't going to work for us. We need the cloth to move with the fire and then eventually get it to disappear. So the way we're going to do that is we're going to use cloth tearing. So let's get that set up. So let's reactivate our cloth modifier and let's go to our cloth tab. Actually, well, before we activate the tearing, let's get it moving first. Otherwise, there are going to be no stresses in the cloth and it's not going to be able to tear. So the way we'll do that is we're going to use this xpExplosiaFX sim to move around the cloth using the velocity data that is created in this sim. And the way we do that is in the Advection tab of the xpExplosiaFX. So and the way we'll do that is in the Advection tab of the xpExplosiaFX object. So let's click on that and we need to activate Advect particles. And we've got all of these different data channels here. Now, xpExplosiaFX creates all of this information: smoke, burn, temperature, velocity, color, and UV. And what it'll do is if we have an advection selected, it will just pass on this data from the xpExplosiaFX solve into the particle. Now, we don't need to pass on the majority of it. We don't need any smoke info, burn, temperature, colour, or UV. We just want the velocity. We just want those cloth particles to be moved by this xpExplosiaFX. So if we do that, let's see what happens. Let's make the xpExplosiaFX just invisible for now. It's still doing its thing. But look, you can see, look, the cloth particles are starting to move. And they're following that velocity information from the xpExplosiaFX. Now, they're colliding with our number 4, and then they're beginning to stretch and stretch and stretch and stretch. And that's obviously not what we want. Where this cloth starts to stress with the number 4, we want it to rip, to be released. So let's set that up. We will go to our cloth tab. Let's go to the tearing tab here. We'll activate tearing. And what we're going to want here is, well, let's just leave it on default for now and see what happens. My guess is that this is going to tear a little bit too abruptly and it might completely disintegrate. Let's just have a look at this tearing shape. Press NA to get rid of those lines. Yes, look, it's starting to tear already, and that's slightly too kind of fragmented for my liking. So what I'm going to do is let's just increase that tear strength so it's a stronger cloth, which means more stress needs to be put on these constraints before that they will break effectively. So now look, we haven't got that initial tearing, but as it starts getting stressed against our geometry, then it's starting to tear, and that's looking really good. Let's just pause that, come out a bit. And this is working exactly how we wanted. And now this is coming up to reveal our next letter, which is our number 4. And of course, because it's reacting with that 4, it's going to beautifully form around this shape. And the beauty with this is that, of course, as it's tearing, our cloth particles, let's make those visible, there's my emitter. The cloth particles are still active, so this still might be creating a little bit of residual burning around the shape of the number 4, which is going to look really, really cool. Right, now we've got this sorted, let's just go to our display types of our groups, and let's just put them on dots, just so it'll just help playback a little bit because it's not having to draw those circles. Let's put them all on dots. Okay, excellent. So we're getting tearing, we are getting advection. The particles are kind of interacting with our number 4, which is our new number, and we're going to get nice bits of fire and wisps of smoke around the edges of this cloth. And this is working absolutely perfectly for us. Let's just keep this running through, and we'll get through to nearer the end. And we kind of want this cloth lifting up out of the scene and being pulled away completely from our geometry. So by the time we're getting towards the end, we almost want it completely out of frame when we go back to the approximation of where our camera position will be. And that's looking great. So by this time, it's virtually out of frame, apart from these stragglers. Let's just hit pause there. Let's make the emitter invisible. Let's make the xpExplosiaFX. Yeah, so we're still going to have a little bit of fire coming out here. But look, we've got nice bits of fire coming up from the geometry, which is going to really nicely outline it. That's working absolutely brilliantly. I am very pleased with that. So that's pretty much spot on. Now, there is an issue here, which we're going to fix, but we're going to fix it after we've got everything cached up. It's the beauty of the fix. And the issue is this. By the time we have got to this stage, we need it to have looked as if this cloth has melted away completely. But the problem is, with this technique, if we make the xpExplosiaFX invisible, it's still here. So how are we going to kind of organically get all of this to disappear with that fire? That is the next challenge. But thankfully, that's a challenge that can be addressed, as I said, after we've got all of this cached to disk. So let's get that cache set up, and then we can move forward onto the final parts of the scene. So let's get that sorted then, shall we? Let's go back to the first frame, and we will let's go to other objects. Let's go to the menu, and we want a cache object. We need to link this up to the folder that we've created. So let's go to the browser, and we want libraries, MoGraph countdown. We want 5 burn cache. Okay, link that up. Excellent. And let's just cache everything. So we will go to build cache, and let's start that along. Okay, so I'll pause that here, and then when we've cached those 90 frames, I'll come back and we'll see how long it took. Okay, so that was a pretty quick cache, 1 minute and 15 seconds, but of course we're on our kind of low resolution xpExplosiaFX settings at the moment, but let's just get an idea of how this is looking, so we can play this cache back. So there we're getting our burn, 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 looking really nice, and it burns away, and I really like these residual bits of fire burning away on the bottom of our number 4. So that's working pretty nicely. Let's just go to the Explosion. We'll go to the Display tab. Let's just reactivate Fuel and Smoke so we get an idea of the smoke sim as well. So that's exactly the look we want, isn't it? Excellent. So what we need to do now is, before we move on to the showing you the technique of how we're going to get rid of our kind of cloth once it's served its purpose, we want it to look like it's burnt and melted away. What we need to do is cache again, but with higher xpExplosiaFX settings. And there are a couple of kind of ramifications of upping your. If we just go to the Solver tab of xpExplosiaFX, we want to reduce the voxel size, which will then make it a much more detailed simulation. Now, the ramifications of that are, you're not going to get exactly the same movement and shape of your gaseous fluid because every single part of the simulation has changed because of this more detailed voxel size. It'll change the burn, the movement, the rate in which it rises. There's all kinds of knock-on effects. So one thing that we're going to do to ensure that we get as close simulation to this as possible by increasing that is we're just going to change 2 settings which will help you. So first of all, I'm going to go down to, say, a resolution of, let's say, try 2. So this is obviously a far more detailed sim, which will take longer to cache. But before we hit cache, we're going to go to simulation. And what we're going to do is we're going to take away the vorticity down from... Well, if we go... We want to change the vorticity and the vorticity radius. But I'm going to try taking the vorticity down to 0% vorticity. And if it's at 0, you don't need to touch the radius anyway, because obviously there isn't any vorticity, so the radius is then irrelevant. So what this is going to do is basically the higher resolution your smoke and fire sim, the lower the voxel size, the less need there is for this vorticity amount, which gives you kind of a fine kind of curl turbulence effect to the volume. It kind of is almost like faking a little bit of fire detail. The lower res your sim, so the higher the voxel size, the more vorticity you'll need to use to give the effect of detail in the fire. The lower the voxel size, the higher the resolution, the less you need that effect. So let's reduce that vorticity amount. Let's try 0, and then we're going to go for a recache. Now, the first cache was a very quick one at our kind of very high resolution, high voxel size, low resolution. It was 1 minute and 15 seconds. So let's see what difference the time is when we have put our xpClothFX to a much lower voxel size of 2 centimeters. So loads more calculations taking place every frame here. So we will build cache, we will overwrite, we'll set this going, and I'll come back to you and for a comparison, tell you how long this new cache took. So that was a longer cache, obviously, with the extra detail. That was 2 minutes and 18 seconds. Now we have much more detail, actually. We'll get smoother playback. If we go to our xpClothFX object, to the display tab, we can change this voxel level of detail now back down to, I don't know, something smaller like 50. And that'll just make it play a bit more quickly. So here we go. So it looks like we've got pretty much the same movement there. What we may find is that we don't get as quick a rise. So let's just kind of zoom into the type of camera position that we're going to have. Something like this. And we're getting a little bit more of a lingering simulation here. We kind of really want this to have disappeared by the time we're getting up to frame 90, and it's looking like we're pretty much there, really. Arguably, we need it just to move up perhaps slightly quicker. So one thing we could try and increase the speed of which it travels upwards, if we go to the xpClothFX, let's go to the simulation, and what we could do is we could increase the gravity. If we increase, let's say increase the gravity, say 12, and this means that we're going to get our kind of gases rising much more quickly. So let's stick that on 12 and we'll give it a recache. And let's see if we're getting a slightly faster movement. So we'll build cache, overwrite. That'll be another couple of minutes. I'll come back to you when it's done. Okay, so that's finished caching now. So let's have a look. We'll play this through. And actually we could deactivate that emitter. We don't need to see that. So we're getting a bit of a quicker rise here with that increase in gravity. Let's just go back to our xpClothFX display, and I'd like to just put it back to fuel. And so the fire's kind of burning out. We still have a little bit of lingering fire here, but remember, we're going to be using a technique to actually get rid of this cloth. By this stage, this cloth will have disappeared as if it has melted. So that isn't an issue for us. And if we've got to the stage where we want, I mean, it's the fact that we've got some floating fire kind of wisping up at this stage is going to actually look very nice. So I'm pleased with that. I think we're in good shape. Excellent. Right, so let's just make the xpClothFX. In fact, we can just deactivate that xpClothFX for now because this is all cached, and we are just looking at our cached cloth particles. So what we want to do now is we want to get rid of this cloth as if it's melting. So how are we going to do it? Well, we're going to combine our xParticles cache with a Cinema 4D MoGraph object. And it's a really fantastic MoGraph object. Very, very powerful. And it's incredibly useful, especially for us here. So what we're going to do is this. Let's just hit ND. Now remember, when we made our cloth object editable, we used the original cloth sim, we subdivided it by 1 with the subdivision surface, and that meant to get back to our render quality, we need to further subdivide it by 1. So let's just do that. We'll bring in a subdivision surface, and let's just bring that down to the bottom. Let's put these subdivisions down to 1, and let's make our cached cloth object a child of the subdivision surface. So now we're back at our render resolution. And if we hit play, obviously this is still cached, this is working, it's ripping apart, but we're at that higher resolution. But now we're at that, what we want to do is we want to use the PolyFX object. So the way we're going to do it is the PolyFX works as a child or a sibling with another object within a hierarchy. So what we need to do is let's put our subdivision surface in a null. So let's hit hold Alt and press G, and it groups it in a null. Okay, let's rename that null. Let's call it cloth. We could call it cloth PolyFX, just so we know. Cloth PolyFX. Okay. And then what we'll do is let's go to the MoGraph tab, and we'll go to PolyFX, and we'll make the PolyFX a child of the cloth as well. So now the PolyFX and the subdivision surface are siblings, and that means that this will work. So what PolyFX does, it's fantastic. It looks at an object, and it makes every individual polygon, it looks at it as if it was a MoGraph clone, which means that you can use effectors. So if I, with the PolyFX selected, if I then go to the MoGraph effectors list and bring in, say, a random, look what's happened to all those polys. They've all spread apart. Why? Well, let's just bring that down. Let's go to our random effector, and in the parameter, by default, it has randomly moved the position of those polygons by up to 50 centimeters on the X, Y, and Z. And it's because in the effector, if we go to the min-max, the max is set to 100% and the min is set to -100. So effectively what that's saying is it's moved those from between -50 to 50 centimeters on the X, -50 to 50 centimeters on the Y, -50 to 50 centimeters on the Z. So if I just make these much smaller amounts, or in fact, instead of doing that, let's just, if I go to the effector tab, if I reduce the strength of that, you can see, look, if we put the strength down to 0, it's back down to our cloth object. And as we increase the strength, it's randomly moving those polygons around. So that's really powerful. And this is, obviously, this is cached, so this is still animating. So it's very, very cool. Now, obviously, we don't want to randomly change their position. That's not what we're after. We want these just to disappear over time. So let's just deactivate, we'll delete that random effector. That was just for a demonstration. So let's, with the PolyFX highlighted, let's go to our MoGraph menu, effectors, and we'll bring in a plane. Now, the plane effector, by default, it's got its position, it's just moving the position on the Y, it's moving every polygon 100 centimeters. So if we go back to frame 1, it's just moved them all, and that's kind of not what we want. So let's take off the position, and now it's back down to what it was. But let's go to scale, and let's put uniform scale, and we could put absolute scale. Let's put -1, and now they've disappeared because we've scaled them all down to 0. So now if I go to my effector tab and mess around with this scale parameter, look, they're all scaling down over time until they disappear. And then they're all gone. And again, this is part of a cached sim, so obviously they're still there. Fantastic. So this is incredibly powerful. We've got this amount of control over a cached xParticles cloth sim. Right, so let's just put that strength up to full. So we are going to set up a very basic fall-off rig here to be able to art direct exactly when we want these to disappear. And we won't actually animate this rig at this point. When we come to rendering this scene, that's when we'll kind of adjust the animation to make it perfect. But let's sort this out. So let's go to the fall-off tab. So I'm in R20 here, so I have the ability to use fields. And with fields, you're able to layer up lots of different fall-offs and use blending modes and get very, very intricate with them. And you'll be able to get some really nice results. But you can also just do this by using fields like an old-fashioned fall-off. So what I will do is I will set up my fields as if it was just using a fall-off, which means if you're using Cinema 4D R19 or below before fields came in, then you'll be able to replicate what I'm doing just by using these fall-offs. So let's just bring in a linear field. So this linear field, I mean, straight away you can see what's happening. If I move this linear field, it's going from the plane effect to not doing anything to making the cloth disappear, which is really great. So there's a couple of ways of approaching it. Probably the easiest would be if we just rotate this plane effector so it's a similar angle as the path of our burn. And we can maybe just make it a much smaller transition. So something like that. And then what we're effectively able to do is just animate this up. So if we hit play, what we want to do is obviously it's the wrong way round. We need to invert it. So let's change that direction from +X to -X. So now it's invisible. And then we move it up, and now they're all disappearing. So that's just all we need to do is keyframe this one parameter, the world Y. And if we hit play, as it starts to burn away, we can then kind of say, right, well, I want you to start disappearing, 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 and we can follow that up. And you can be much more intricate with this. You can be much more savvy with it. You could maybe use a noise fall off. If you're in field, you'd be able to layer up to get a much more interesting, even use an animated noise, so you get a much more interesting dissolve. But for our purposes, because this is hidden behind the fire anyway, something as simple as this is going to be enough to get those polys to disappear when we need to, and make sure that by the time it's all been stripped away here, everything's going to be made invisible, and we're left with our wispy fire. Fantastic. So let's leave that. So we have our cached scene, which is working beautifully. We have our xpExplosiaFX information. We have our tearing cloth, and we've set up this rig, which we'll be able to manipulate at render time to make sure that all of our cloth has disappeared by the time we get out of that frame. So that is it. Everything has been done in that scene, ready for us to prepare the majority of that technique at render time. Excellent. So now we're ready to move on to the next scene, which is going to be, instead of this obviously being a static 4, we're going to set up our fantastic 4 crumbling effect, which will then reveal the number 3 underneath. And that's going to be our next project file.